Hello everyone, I'm Professor Ken Octobre. In this second part of synthesis of mechanism, we are going to study the different graphical methods used for the function generation and the body guidance. The session objective to know, that means student will able to know about the synthesis of the mechanism for the graphical method, and after learning this, they can apply this knowledge to synthesize the mechanism using graphical method to design a new mechanism. Okay. Now in this graphical method, there are two types of method. One is the inversion method and second one is the relative pole method in the function generation. Okay. Now in that inversion method, we are going to, our focus will be on the 4-bar mechanism and the 3RP chain, 4R chain and the 3RP chain. Again in that 4R chain and 3R chain, one is the 2-position synthesis and the 3-position synthesis. What is significance of 2-position and the 3-position is that the 2-position theta 1 theta 2 will be given to you and phi 1 and phi 2 again given to you. From this you have to design the mechanism. You have to find out the link lengths of that mechanism. In this 3 position theta 1 theta 2 theta 3 phi 1 phi 2 phi 3 will be given to you. Again in 3RP chain, that means slider crank mechanism, that 2 positions of the crank and the output link is the slider, that 2 positions of that slider will be given to you. From that you have to design the mechanism. In this 3 position just like this, in case of relative pole method also you need to follow the same and you have to design the mechanism. Now we'll start with the inversion method. Now graphical synthesis of using the inversion method. First of all, we are going to consider the 4R chain, 2 position synthesis, theta 1 theta 2 phi 1 phi 2 are given to you. Okay, again what we need to do or how to do this, you have to just draw one horizontal line. Next you have to mark one, you have to take suitable distance. You can assume any distance, that choice depends on you. You have to mark this, that fixed link AD, you have to assume this distance. Okay, next you have to mark the first position A dash A B1 dash or A B1, and from this position you have to mark the second position. Okay, at an angle of theta and at an angle of theta 1 2. Theta 1 2 is equal to theta 2 minus theta 1. Theta 1 and theta 2 are known to us. Phi 1 and phi 2 are given to you. From that you have to calculate theta 1 2 and phi 1 2. Theta 1 2 is equal to theta 2 minus theta 1. Phi 1 2 is equal to phi 2 minus phi 1. Okay. Now in the next step you have to join this D to D B2. From this position you have to take an angle of phi 1 2 in the clockwise direction and you have to draw one line. After drawing this line, you have to take db2 distance in compass. From this, by placing that pointer at the point D, and from B2 you have to draw one arc which intersect that line. You will get the point B2 dash. Okay, after getting that B2 dash, next you have to join this B1 B2 dash. B1 B2 dash will join this B1 B2 dash. Next you have to take the perpendicular bisector. These two sides are same and this is the perpendicular. You have to draw the perpendicular bisector. After drawing this perpendicular bisector, you have to consider any one point on this link, any one point on this line. You will get the point which is the C1, and this point you have to join with D and you have to join with this P1, and you will get this 4-bar mechanism. This is the phi. This is the link number 1, this is the link number 2, this is the link number 3, and this is the link number 4, and you have to measure all these 4 links, measure the lengths of all these 4 links, and you will get one mechanism which satisfy these two conditions. When theta is equal to theta 1, phi will be the phi 1. When theta is equal to theta 2, phi will be phi 2. This is your first method, which is the 2-position synthesis using the inversion method. Now we are going to study the 3-position synthesis. Again, you have to draw one horizontal line. On this line, you have to fix this distance AD. Next, you have to draw one line at an angle of theta, which is of B1 dash. This is of B1 actually, not the B1 dash. Okay, from this initial position, this may be theta 1 also, that you can take this as a theta, or you can take any arbitrary angle theta. You need to draw the second position of AB2 at an angle of, with this position, that angle is of theta 1 2. That theta 1 2, in this case that three positions are given: theta 1, theta 2, theta 3, phi 1, phi 2, phi 3. Theta 1 2 is equal to theta 2 minus 1, and theta 1 3 is equal to theta 3 minus 1. Again phi 1 2 is equal to phi 2 minus phi 1, and phi 1 3 is equal to phi 3 minus phi 1. Like this, these positions are given. You have to draw these positions: theta 1 2, phi 1 2. Okay. Now you have to join this B2D. From this position you have to take this angle phi 1 2. You will get one position. Again you have to draw one arc by taking B2 as a radius, D as a center. This arc intersects this line at point B2 dash. Next again you have to join D B3 dash. Next again you have to take an angle of phi 1 3 from this position. You need to draw one line. Again you have to take this db3 dash as a radius, again d as a fixed point. You have to draw one arc. This arc intersects this line at point b3 dash. Next task, you have to join b1 b2 dash. Next b2 dash b3 dash. Actually this point is a b2 dash, this point is the b2 dash, this point is the b3 dash. Okay, b1 b2 dash b2 dash b3 dash. Next you have to take the perpendicular bisector of b1 dash b2 dash and b2 dash b3 dash. These two are the perpendicular bisector. Perpendicular bisector like this. These two are intersects at common point, and that common point is the C1. Now our procedure is over. Now you have to join this C1 to D and D to this B1. And you will get this 4-bar mechanism: A, B1, C1, D. For the, which satisfies these three conditions: theta, when theta is equal to theta 1, phi will be the phi 1; theta is equal to theta 2, phi will be phi 2; theta is equal to theta 3, phi will be phi 3. This is your input link number 1, 2, 3 and 4. You need to measure these link lengths, and this will be your final mechanism and final answer. Now we are going to study the inversion of the 3RP chain slider crank mechanism. In this case, first of all, we are going to consider the two position synthesis. That means theta 1, theta 2 for crank positions are given to you, and respective that slider positions are given to you, S1 and S2. Here also we need to calculate theta 1 2 is equal to theta 2 minus theta 1, S1 2 is equal to S2 minus S1. While drawing this, now you have to just draw one horizontal line. You have to mark one point, which is the point A. Again you have to draw one offset line. This distance is equal to E. That distance may be given to you, or you have to assume this distance, that E distance. Now on this line you have to mark any one position of the slider, and you have to take the second position at a distance of S12. You have just marked the two positions of the slider, C1 and C2. Okay. Now you have to join AC2. You have to join AC to this distance, these 2 points. Next, from this position you have to draw one angle. You have to draw an inclined line having angle of theta 1 2, and you have to draw one arc which intersects this line at a point of C2 dash. Okay. Now you have to join C1 to C2 dash. You have to join C1 C2 dash. You have to take the perpendicular bisector of this. This is the perpendicular bisector, and on this perpendicular bisector you have to assume or consider any one point. Here you have to consider or assume any one point, which is the B, and you will get this 4-bar mechanism, 4, that means 3RP chain mechanism. AB is the crank, BC1 is the length of connecting rod, C1 is the slider, and you need to measure these distances. You need to measure this distance AB and the BC1. If we design this mechanism, when crank rotates through an angle of theta 1, that position of S1 will be the position of slider will be the S1. When theta is equal to theta 2, that is 2. that position of slider will be the S2. Next, we are going to consider the three position synthesis of the 3RP chain. That means theta 1, theta 2, theta 3, S1, S2, S3 are given to you. Again, you have to calculate theta 1, 2, theta 1, 3, S1, 2 and S1, 3. Okay, again, you need to mark this point theta 1. Again, you have to draw one offset line. This E that you need to assume. Okay, again, you will mark the first point, first position of the slider. By taking S12 distance, you need to mark the second position. Again, by considering the S13 distance, you need to mark the third position, C1, C2, C3. Okay. Now you have to join C2A. You have to draw one R. You have to draw one inclined line at an angle of theta 1, 2, and you need to draw by taking this A C2 as a radius. You have to draw one arc which intersects this line at point C2 dash. Okay. Next, again you have to join AC3. You have to draw one arc and you have to draw one inclined line. These two are intersects at common point. That common point is the C3 dash when you have to take this angle of theta 1, 3. Theta 1, 3. Now you have to join C1, C2 dash, and you have to draw one perpendicular bisector. This is the perpendicular bisector. Again you have to join C1, C3 dash, and you have to draw the second perpendicular bisector. These two are intersects at common point, and that common point is the B. That common point is the B. Now you have to join. You will get the position of the crank. That means one end of the crank. You have to join A to B and B to C. Now this is your crank, and this is the length of the connecting rod. You have to measure these distances, and you will get the that 3RP chain. When we rotate theta crank through an angle of theta, you will get the S1, theta 2, S2 and theta 3, S3. In this way, using this inversion method, we can design the that slider crank mechanism. Now we are going to study the second method, which is the relative pole method. In this relative pole method, again we are going to consider the 4R chain, 2-position, 3-position synthesis, and slider crank mechanism, 2-position synthesis and the 3-position synthesis. Now this is the we are going to study the 4R 2-position synthesis by using the relative pole method. Just try to understand how to draw to this synthesis. Again, before that means theta 1, theta 2, phi 1, phi 2 are given to you. Again, here we need to calculate theta 1, 2 is equal to theta 1, 2 by 2, which is theta 2 minus theta 1 by 2, and phi 1, 2 by 2 is equal to phi 2 minus phi 1 by 2. These positions are given to you. Theta 1, 2, phi 1, 2, phi 2 are given to you. Next, I will just mark one horizontal line. You have to fix this distance. You can assume this distance AD. Now, in this case, you have to draw a line through point A at an angle of theta 1, 2 by 2. In this case, why we have taken this angle in the clockwise direction, anti-clockwise direction? Because in this case, we are just assuming that link rotates in that input link rotates in the clockwise direction. If you are assuming that link rotates in the anti-clockwise direction, that input link rotates in the anti-clockwise direction, you have to take this angle into the clockwise direction, just like this. But in this case, we are just assuming that input link which rotates in the clockwise direction. That's why we have to take this theta 1, 2 by 2 angle in the anti-clockwise direction. Okay, we have taken this angle. Again, from this point D, again you have to take this angle in the clockwise direction, anti-clockwise direction, which is of phi 1, 2 by 2. These two are intersects at common point, and that common point is the R12, which is called as the relative pole for these two links, input link 1 and 2. Okay. Now we'll just consider the any position of the crank, that means the input link, and we'll mark that position. Next, we just join this. Okay, before this, we'll just mark this angle, which is of psi 1, 2. You have to just mark the angle between this or the included angle of this relative pole. Next, you have to join this R12 to B, and next from this position that R1 to B, you have to take an angle of 512 in the opposite direction. This direction is the clockwise. That you have to measure this angle, and same angle you have to take over here. You will draw, you will get one new line. On this line you can assume any one point, which is the point C. Now you have to join BC and CD, and you will get this 4-bar mechanism. 1, which is the fixed link, 2 is the input link, 3 is the coupler, and 4th which is the length of the output link. In this way, you will get the 4-bar mechanism by using the relative pole method for the 2-position synthesis of the 4R mechanism, 4R chain. Now we are going to study the synthesis of 4R chain using the relative pole method for the 3 positions: theta 1, theta 2, theta 3, phi 1, phi 2, phi 3. These are given to you. Again, you need to do some calculations. Theta 1 2 by 2, you need to calculate theta 1 2 by 2, theta 1 3 by 2, phi 1 2 by 2, and the phi 1 3 by 2. Okay, that you need to calculate. Now we'll start the procedure. You have to draw one horizontal line which is of AD. You have to assume this distance, this AD, which is the fixed link, that you have to assume. Next, you have to take this. You have to draw an inclined line through the point A at an angle of theta 1 2 by 2 in an anti-clockwise direction, because in this case we are assuming that crank is rotating or input link is rotating in the clockwise direction. If in your problem statement it is mentioned that crank is rotating in the anti-clockwise direction, in that case you need to take this angle into the clockwise direction. Okay. Again, through the point D, you need to calculate the phi 1 2 by 2. You will get the first relative pole R12. Okay. Next, again through point A, you need to draw again one inclined line which is of theta 1 3 by 2, and through point D again you need to draw the line theta 1 3 by 2. You will get the second relative pole which is the R13. Next, you have to draw one line through point A which is the input link by assuming that any angle. Next, you have to measure the included angle of the relative pole phi 12, and you have to join that R12 to B, and through with reference to this R12 line you have to take this psi 12 angle in a clockwise direction. You will get one inclined line. Again, you have to join R13B. Before that, you need to calculate this angle phi 13, and same angle you have to take with reference to this new line R13B, and you will get one new line. These two lines intersect at common point. That common point is C. Next, you have to join B to C and C to D. This is the 4-bar mechanism. If we give the motion to theta 1, it will output link will give you the phi 1, theta 2 for theta 2 will give you the side phi 2, theta 3 phi 3. Here one important condition is that you need to measure this psi 12, and you have to draw the line with reference to this R12B by taking this psi 12 angle in the clockwise direction. Now we are going to do the synthesis of slider crank mechanism for the 2 positions using the relative pole method. Again, theta 1, theta 2, S1, S2 are given to you. Now you need to calculate theta 1 2 by 2 is equal to theta 2 minus theta 1 by 2. S1 2 by 2 is equal to S2 minus S1 by 2. Now here you need to draw one horizontal line. On this horizontal line you need to fix one point A, which is that rotation point. Next, through this point you have to draw one vertical line. Again you have to draw one line which is parallel to S12 towards left. See, in this case again we are just considering this crank which is rotating in the anti-clockwise direction. Crank is rotating in the anti-clockwise direction. That's why here we are taking, that means when that crank is rotating in the anti-clockwise direction, that slider will move towards this position, and that S12 that we have to take it towards that slider moving towards the left, you have to take S12 towards right. Okay, again with this vertical you have to take this angle into the clockwise direction, which is of theta 1 2 by 2. These two are intersects at common point. This is here you will get the first relative pole, which is the P12. Here we are just considering this point as a P12 relative pole. Okay, next you have to draw any one position of the crank which is at an angle of theta. Next you have to join, you will get this point B1. This point B1 is at this location. You have to join these two P1 B1 to P12, and here you have to measure this angle, include angle for this relative pole, which is the gamma, and from this position you have to take the same angle in the anti-clockwise direction. If you take this angle, okay, next on here you have to consider any one point on this new line. You will get the point C, which is the position of the slider. Now you have to join B to C1. That here you have to measure this eccentricity. You will get the new position of the slider. Okay. Now in this case you need to measure this length, which is the crank, and B1 C1, which is the length of the connecting rod, and you need to measure the eccentricity. Using this you can do the synthesis of 3RP chain using the relative pole method. Now next task, now we need to do the 3-position synthesis. Now in this 3-position synthesis, 3 positions of input link theta 1, that means the crank angle theta 1, theta 2, theta 3, and respective positions of the sliders which are given to you, S1, S2, S3. Here again you need to calculate S12 by 2, which is theta 2 minus theta 1 by 2, S13 by 2, which is the theta 3 minus theta 1 by 2. S12 by 2 is equal to S2 minus S1 by 2, and S13 by 2 is equal to S3 minus S1 by 2. Okay. Now again we are going to start the procedure. You have to draw one horizontal line. You have to mark any one point A. You have to draw one vertical line through this. This is the center of rotation of the crank A. Again you have to take this S12 by 2. You have to draw one parallel lines by taking offset distance is equal to S12 by 2, that we already calculated. Next, through this point A you have to draw one inclined line at an angle of theta 12 by 2 with the vertical. You will get one relative pole, which is the P12, or here I have mentioned this is of R12. Next you have to take S13 by 2 distance, offset distance, and again you have to draw this parallel line with this reference line. Again here with this vertical line you have to again take that theta 13 distance, and these two lines intersects at common point. That common point is the R13. Okay, now you have to draw any one position of the crank at an angle of theta, which is of B1. Next you need to measure this angle of gamma, and you have to join this R1 to B. You have to join this R1 and B, these 2 points that you need to join. With this you have to take that angle gamma with this new line, and you have to draw one line. Okay, next again you have to join, before that you have to measure this angle psi with this included angle of this R13. Again you have to join this R1 to R13 to B, and you have to take that angle psi. These two lines intersect at common point. That common point is this C1. Now you have to join B to C1. You will get this offset distance E1. That means this is the offset slider crank mechanism, and you will get this position. And in this way you can do the synthesis of the that slider crank mechanism. This is the offset slider crank mechanism using 3-position relative pole method. Now we are moving to the last. Now we are studying the last part of this synthesis, graphical synthesis, which is the body guidance. In this body guidance, 3 positions of the coupler links are given to you, and you need to find out the length of the input link, output link, position of the position of the pivots, and the position of the position and the orientation of the fixed link that we need to find out. Now first of all you need to draw one coordinate system. In that coordinate system, this is the first position of that coupler link. that a1 is of 2 comma 0, b1 is of 2 a1 is of 2 comma 6, b1 is of 2 comma 0. That means length of this vertical link is of 6. Okay, next, second position. In the second position, b2 is of, that location of b2 is given 5 comma 2. See, you have to draw that positions of all these links as per the true scale. You have to draw that horizontal line, and that you need to consider these distances into the centimeter. That means from this you have to consider the distance, horizontal distance is of 20 centimeter. Through this we need to find out that vertical distance is of 60 mm, and you need to find out this location of this point a1. Again, you need to define this point b2, which is having the x and y coordinates. X coordinate is 5 centimeter, y coordinate is the 2 centimeter. You have to draw one inclined line which is of 50 degrees, and that link length that you need to calculate from this, which is of 60 centimeter, 60 mm, you will get the point a2. Again, in the same fashion, you need to draw the third position b3 a3. Okay, after drawing these three positions, next task, you need to join a1 a2 and a2 a3, a1 a2 a2 a3. Next, you need to take the perpendicular bisector of this a1 a2, and you have to join this line. Again, you need to take the perpendicular bisector of a2 a3, and you have to join the line. These two are intersects at common point. That common point is the OA. Again, you need to join this b1 b2. Just try to understand, this is the b1 b2, b1 b2. Next, you need to join b2 b3, b2 b3, this b2 b3. Next, you have to take the perpendicular bisector of these two. These two are intersects, again one common point. This is the OB, which is the second pivot. Okay, next you have to join this OB to B1 and O1 OA to A1. This is your 4-bar mechanism, in which OA is the fixed link, OA OB is the fixed link, OA A1 is the input link, A1 B1 is the coupler link, and B1 OB, which is the output link. These are the fixed point, and this is the 4-bar mechanism. When we allow to rotate this mechanism, this link in the second position, in the second condition its position will be like this, and in the third condition its position will be like this, as we give the rotation to this. In this way we can obtain the synthesis of the body guidance, and we can obtain the positions of these 4 links, position and the orientation of this input and output link. Again, here you need to find out the coordinates of this O1b, OB, and the OA. Okay, with this I'll finish this session over. Okay, these are the 4 links. With this I'll finish this session over here. In this session, what we learn the graphical methods. First one is the inversion method, second one is the relative pole method, and third one is the body guidance. In the relative pole method, in the synthesis, that means inversion method, we have started with the 2-position synthesis of the 4R chain. Next, 3-position synthesis. Next, we have started with the slider crank mechanism, 2-position synthesis, 3-position synthesis. In the inversion method, we have started with the 4-bar mechanism, 2-position synthesis, 3-position synthesis. Again, in the relative pole method, we done the that synthesis for the 3RP chain. In that 3RP chain, 2-position synthesis and the 3-position synthesis. Again, in the last part, we have studied the body guidance method. In this body guidance, 3 positions of that coupler links are given to you, and using this you need to find out the position of the fixed that pivots, and that link length of the input link and the output link and the fixed link. This is the task. With this I will finish this session over here. Thank you very much for your patience listening. Thank you.